Classic Turning is set apart from our competition because we're a full-service supplier. And with that, we've got a staff of engineers that can assist our customers in optimizing their design for manufacturability. We also have a digital printer such that we can make a rapid prototype, a plastic part, right from the customer's solid model or their drawing. What also sets us apart is our responsiveness. We can respond very quickly to customer inquiries, and a lot of times we can provide a finished machine part that same week, or when really needed, that same day. We received this model this morning. Jeff and Wes are analyzing it as far as what tools, what the setup time will be, what the tool path and cycle time will be. And we're also doing a rapid prototype of what you see on the screen here, so that we'll have an actual representative of the part so that we can determine how we're going to fixture it when we're machining it. Shown here is the digital printer making a model of the customer's part. This facility is 33,000 square foot. Our other facility, we lease 29,000 square foot at our second Argyle Street facility. Shown here is some material being brought in from one of our bar stock suppliers. We have several in Michigan and throughout the United States that provide us with our material. Customer service works with our customers to provide a quote, and then it's turned into an order, and as shown by Carol, we'll set it up. It'll be programmed by Jeff. Then when we release the job out to the production floor, one of the first steps is determining the bar stock, what's called out on the order. So in this area is shown our material receiving area, and where we cut off into lengths or slugs that will be put into the machine. After the material is determined or it's cut to length, then it will go into the different departments. Here at our South Street facility, we have 3 different departments: the mill department, our drop-in department, and our contract department. So we got Matt Bueller. He's our lead man in the mill department area. He's setting up a job. If you can talk a little bit about what you're doing, about the part, the setup you're doing.
So it comes in as a solid piece from the lathe, and we'll take it and we'll saw it where we need it to be for our operation. Saw part off. That'll just be discarded, and we'll come off like this, off the lathe. And after we saw it, then we just move on to the next stop. Here. And that'll finish the inside of our part where we need it. Thread our holes, put our wall thicknesses in, pretty much finish everything on the inside of the part. Then we just have some small minor operations that'll be left. Loaded up into here, just put our pockets in on the outside. And then 3 more work holes on that machine. Put our 2 3/8 holes in, and then engrave the part number right onto the part.
Shown here is our drop-in department. The cells are basically laid out with 2 lathes and a mill. First operation, second operation, and then the milling operation at the end. Our more senior machinists, more trained, versus in the contract area where we have more of the repeat jobs that are under contract, more repetition in the contract area, and also larger lot sizes would be in the drop-in area. What's your typical setup time for a job? You're changing over 4 machines.
Our typical setup time is between 2 and 3 hours.
All right.
And a typical run card is about 5 minutes.
All right. Shown here is our tool boss tool management system. From here, the operator can wand in, identify the tool that they need. Maybe they've broken a tool or they've got a worn insert. They can pull out what they need. When a job gets sent out to the production floor, all the tools, all the tool holders and the inserts are there for that machinist to run that job. So we'll go in the tool room in a minute. Tooling is critical for a machine shop. I'd like to introduce Mark Stetler. Mark, can you talk about when we get an order and we got to make up that tool cart, some of the steps that you've got to go through in order to get everything to that cell?
We got a tool sheet that basically tells us what their work holding is and what their tooling is that they need for the specific job. We'll print it out on the computer, bring it out, pull all the tooling out. We got all the tooling in here. Job boxes are upstairs for tools that are kept specifically for that job. And we'll pull that down and put the tools and the jaws out, put them onto a cart, roll them out to their cell so they never have to leave their cell when they're doing the setup on it.
Shown here is the latest addition to Classic Turning's South Street facility. This is where we have our contract department. Once again, broken up into work cells. This particular one has 3 machines, CNC machines. Also shown here is the tool cart with all the tools, all of the fixtures. Could you tell us about hog outs? What is a hog out?
It's basically a part that's made from a round slug or a bar stock, and we turn it into we call like an elbow, which is a part like this. That's all complete.
What is the material you're working with there?
This is titanium.
Okay.
Yep. Pretty expensive material, so what we do is we do a lot of setting up with aluminum, so it's a lot less cost effective. So when it gets into titanium, everything's all dialed in.
A job is machined in one of our departments, either the mill department, the drop-in department, or the contract department. Depending on the customer requirements, they may require an AS 9100 inspection report that Carol showed you earlier. Those inspections will be done here in our gauge lab. We're talking about how a part is machined, and then depending on the customer requirements, they may require a AS 9102
right.
Inspection report. Can you share, what's entailed? What is an AS 9102?
An AS 9102 is basically a first inspection report for the very first piece off the machine. It's giving you documentation basically from start to finish of the part. We're working on some fuel injectors, and these things are so small that I have to bring them into the crib and actually deburr inside of these holes under a microscope. And that's the only way we can do it. And we're taking that initiative to make sure that there are no burrs in them injectors, because if you've got anything about cars or automotive, if you get a burr inside your injector, you're not going to have any fuel going to the motor. So